Yeah, we do a revision today. If you have any question, you can put it in meeting chat or you can talk with me. So, Zafir, Muhammad Nabil. Okay, so we will start recording, yeah? So we start with separable variables. Okay, separable variable. Please see the slide. So if you have any question, you can type, and then at same time you can ask me question immediately. So this is a revision for your test 1. So chapter 1 is about separable variables equations, and this is the technique, this is method how to solve basically first. So you see 1.1 in red color. So I'm using this what we call snapshot to show you. This is separable variable, very fundamental method, because 1.3 linear equation. In linear equation also, sometimes you have to use this integration, and then followed by 1.4 exact and non-exact equation, and then 1.5 Bernoulli equation. So why separable variables? So in order to answer that question, so we see the next slide. So we want to first identify. First, we have to identify the differential equation. Identify meaning we want to know the form. Identify meaning what is the form of the differential equation. First order only, because we cannot use this for second order, third order, and other higher orders. We only identify for the first order, and then we solve. What do you mean by solve in this particular topic? Solve meaning here, the technique that you are going to use is integration. So you must be very good at integration. Integration of what? So you have many types of functions, such as polynomial x squared. You must know how to integrate x squared. And then you have ex, exponential function. How to integrate ex. So you can refer this in any calculus book, or you can just Google it. You can find the integration formula for e power x. And then ln x, natural logarithm x. how to integrate ln x. After that, you must know for trigonometric function, sine x, cos x, tangent x, and so on. And then hyperbolic functions, sinh, cos, tang. And when we talk about integration, when I said integration of polynomial, what is the integration method? This one is what we call in-depth studies, more detailed. So under integration, you have many methods. The famous one is integration using power rule. Integration of power rule. This is a reverse process of differentiation. So the integration is a reverse process of differentiation. Because if you differentiate the function, you get the answer, you integrate, you get back the original function. So one of the famous method is using the power rule. For example, how to integrate x squared. So the answer is x power 3 over 3 plus c, constant. That is indefinite integral because you have a constant c. And then another famous method of integration is integration by parts. Integration by parts, that is integration of u dv equals to uv minus integration of v du. Of course, if you memorize it, it will be very useful. If you cannot memorize it, then you have to refer to reference book. So we see the form. The general form, first order ordinary differential equation, you see here, f x y y dash equals to 0. Meaning f is the function of x. X is input. Y is output. Y dash is the derivative, dy dx. So we are talking about first order. So how to write first order? First order meaning the dy dx. That is the meaning of first order. So first you must know the form first, general form. From general form, because when you integrate any function, you get the constant c. This is what we call indefinite integral. Definite integral, you have a lower bound and upper bound, so you don't have the constant c. This is a major problem. As you know, in numerical analysis, you already studied 3 methods. Number one is Euler method. You see, they gave you the initial condition. Youn's method and Runge-Kutta all have an initial condition. Without initial condition, they cannot start the iteration. That is the setback of numerical methods. But for this separable variables technique, you no need to have initial condition. But you will have the constant c in the final output. This constant c is the problem. You cannot say you already solved completely because the c is still unknown. So the problem is solve only 90% because you don't have that c. So you have to find the c. For that, you need initial condition. Okay, now we see the next slide. The previous one is general form. Okay, first order general form must have these 3 terms, x, y, y dash. So we have to rewrite the first order in this form. You must write. After that, we go into the techniques. So the first order DE, the form is dy dx equals to gx hy. First order is said to be separable or to have separable variables. What is the meaning? Meaning the dy dx equals to gx. This is the function of x input, and hy is the y variable. Of course, y is the output. We want to find the y. We want to solve this dy dx. We want to find the output. What is y? So y is, for example, x squared plus c. Then you put x and y, you can find the c. And then you, after finding c, if you put any value for x as an input, you get an output. So we write this form, but another book will write in another form. So if you look at the different book, they will write in a different form. So this is what we call style, okay, style of writing. But the final answer will be the same. Now, when we say identify that this is the first order. So identify by looking at the form, because later on you have a separable, and then you have exact, and then non-exact, and then Bernoulli. So all these are first orders. So why it is not linear equation? Why it is not exact equation? Why it is not exact equation? Why this is not Bernoulli? So you must identify. If you don't identify, then the method you apply will not be the correct one. So you ended up with the wrong solution. Your output will go wrong. So before we apply method, there are three things here, class. One is identify, I. Second one is the form. And third one is the method. Of course, the final one is the output. IFMO. IFMO. Meaning, first you have to identify, and then the form, and then apply method, and then get output. So there are 4 steps. If your identification is wrong, then it will affect the form and the method. So identification and form together, this is one group. Identification and form is very important in order to apply the method. Because if you identify this is not separable, let's say this equation you say linear, then you apply the method, linear method. So the output is wrong. Because this is not linear, this is separable. So now, once you may ask, given the question is not in this form, then the problem becomes challenging, because you have to reform the question. That is another step. Actually, this one is what we call ready-made. It's already in the separable form. But it doesn't mean that every time when you see the problem, it is in this form. The answer is no. Because question can be in any form. So you have to form this into separable. If can, it is not guaranteed. This is the problem. The problem here is whether it is separable, separable or not separable. This is another thing. We call it this decision making. So you decide whether this is separable or not by looking at the form. So it requires one more step before you form. So that format is not necessary in this form. So you have to form. And if it's not in this form, then we cannot apply the separable method. That means it is in another form. For example, Bernoulli. So we have to look at all the possibilities. So once you have dy dx equals to gx x hy, you see g function of x only. Yeah, this is one function, h function of y. Now look at this example. This one, they already told you separable. Why it is separable? Because you have y squared dy dx left hand side equals to y squared x e power 3x plus e power 4y. This e power 3x plus 4y you can write as e power 3x multiplied by e power 4y. You can segregate this. You see here, they already segregated this. Because you have to do the grouping. You must put x. Now we go into in detail. How to handle now this part. How to handle this part? You have to do grouping. That means y squared on the here, put it here, y squared, x, you put it here, e power 3x plus 4y is e power 3x multiplied by e power 4y. So you have x function, x e 3x, and then y function, y squared e 4y. So you have gx is x 3x, hy, y squared e power 4y. Now, so if you want to integrate dy dx equals to x e 3x multiplied by y squared e power 4y. So you bring y, all y variable left hand side. So dy over y squared e power 4y and then x e 3x dx. So you integrate left hand side, right hand side. So y power minus 2 e power minus 4y dy equals to integrate x e power 3x dx. So y power minus 2 e power minus 4y dy. This one you can try by integration by part.
Sorry, sir.
Yes? Yeah.
We cannot see the slide, sir.
Why? Hello?
Yes.
Yeah. I don't think we can see the slide. Okay. Oh, what happened? Wait. I already uploaded. Hello?
Hello, sir,
Can
but
you
many
see?
of us cannot see the slide. I don't know why.
What about others?
Others
We can't
also.
see also. So maybe you can try to upload again.
Wait a minute. Huh? Yeah. Separable variable. Can you see the slide now? Already uploaded. Please share. Hello?
Still cannot, sir.
I think you are not in Microsoft Teams. You go and click today's lecture, Mechanical Engineering. What about others? Purushottaman? Are you there, Purushottaman?
Yes, sir, but I still can't see. I'm in the class, but I
Uh-huh.
can't see. Just now only the front page, it was just froze just like that only in the front page.
No,
Now
I can
we can't
scroll.
see.
Now can.
Now we can't see at all.
No, I already uploaded separable variable. Slide number 7.
We can't see.
I already share ready. Separable variable. Can you open the separable variable? Anyone can see? Please share it. Hello? Anyone? Muhammad Amirul, can you share the slide? Patricia, you said you can see the slide? Hello, Patricia?
Hello, sir. I
Yeah.
can see the slide just now, but right now, no, I cannot see any slide.
Why just now you can see?
Yeah,
I don't
I see
understand.
that, but then it not moving, just front, and then I rejoin back, then no slide.
Are you in Microsoft Teams?
Yes, sir. I'm in Microsoft Team.
Under Mechanical Engineering Group.
Yes, sir.
Yeah, Farasha, you have question? Okay, in that case, can you open the slide? You go in Ulearn, open the slide. Because I already opened. I already shared already. Yeah. Yeah, Farasha, any question? Farasha? Okay, you open the slide. Okay, can you open the slide in Ulearn? One point two. Can you open the PDF slide? 1.2. Yeah, when can? Why? What happened? When can? Are you there? When can? Hello? When can? Hello? When can? Are you there? Can you open the slide now? Hello? Hello? Can you answer me, please? Hello? When can? Patricia, can you open the slide? Shall we
Yes, sir.
continue or not? Huh?
Yes, can. I mean, we
So,
open our own slide.
yeah. Okay, shall we continue, Muhammad Azhar? Okay, so examples, yeah? Slide number 7. Go to slide number 7, please. Please go to slide number 7. So, number 7, they just want you to see whether this is separable or not. So, GXHY. So, the GX all right hand side, HY left hand side. So, left hand side integration y power minus 2 e power minus 4y dy. Right hand side integration of x power e3x dx. Whether this integration can be solved or not depend on what method you want to use. So at the moment, we are not going to solve this, but just to show you, this is separable form. So the form is separable. But I think in this case, the right hand side, you can try using what we call integration by parts. And the left hand side, I think it will be very difficult because you have y power minus 2. So I'm not sure whether this can be integrated, can be integrable or not. So at the moment, we just leave this aside first. We are not going to solve this. Just to show you that this is separable form. That means it gives you a green light to apply the separable method. That means you can integrate dy left hand side, dx right hand side. Integration of dy all left hand side, you must put the integration sign. I will show you in the next example. And the right hand side, e power 3x dx, all integration. So here they are not solving this because this is just to show this is separable. Now, the second one, dy dx plus equals to y plus sine x, is not separable. The reason is we cannot put this in the form of h y gx, the product. It should be product. Otherwise cannot. So this one we cannot solve at all using separable method. This one maybe it is in the linear form. So we don't handle this. So at the moment we just leave it aside. And the first one you can try. You go back and then you can try. Write down here, integration of y power minus 2 e power minus 4y dy. Left hand side. Right hand side, integration of x power x multiplied by e power 3x dx. So the integration, I don't have the integration sign. So you have y power minus 2 e power minus 4y dy equals to, you can try, integration of x multiplied by e power 3x. So this is the separable form. Write down here. Y power minus 2 e power minus 4y dy. So we bring y term all left hand side equals to integrate x multiplied by e power 3x dx. Can you get this, Muhammad Azwar? Muhammad Azwar, are you there? Hello? Can you reply, please? Yeah. So whether this can be solved or not is a question. So the suggestion is we use integration by parts. Write down, yeah. You can try later. So integration by part is the method. So separable is the form, and then of course the method comes after you what we call segregate. What is the meaning? You bring y terms all left hand side. Y terms left hand side equals to x terms right hand side. It is up to you, class. Y terms left hand side and the x term right hand side, or x term on the left hand side, y terms on the right hand side, because at the end of the day we want to find y output in terms of function of f function of x. This is your output, so this will be your output. This will be your output. So we are in the process of going to get output. So that's why the IFMO is important. Identify, form, method, and output. If more. IFMO, method. Identify, form, method, and output. If more techniques. First, you have to identify, then the form, then method, then output. So integration by part is the method. Integration by part is a method. So whether this thing can be solved or not, y power minus 2 e power minus 4y dy equals to integration of x e power 3x dx is the question. So it is not necessary integration by part can solve. Yeah, Muhammad Firdaus. What happened, Muhammad Firdaus? Are you there? Hello, Muhammad Firdaus? So if you have any question, please ask, class. Now we are in slide number 7. Okay, go to slide number 7. Example 2. Now, method of solution. So divide both sides of the separable DE. So this one, dy dx, gx hy, it is up to you how you do it. Left hand side dy, right hand side dx. So this one, divide both sides of the separable dE by hy, then you get another equation. As I said, left hand side py dy, right hand side the gx dx. Why they put py? Because 1 over h over y. 1 over h over y is py. So this is called separable. Any question, class, so far? Any question, class, so far? Muhammad Firdaus? Available. Okay. Thank you. All right. You have to open the slide number 8, yeah? Okay. Now, step 2, from this form, now you see, integrate both sides of the equation. So, integrate py to y and integrate gx dx to get a new py plus a. The a is more a, that is one constant, and integrate dx, you get the function big x plus b. But this b minus a is another constant. So we need only one constant, not two constant. Combine a and b. So the final answer is py equals to gx plus c. I try to understand this, class. If you have any question, you can ask me now. A and b are constant, but we no need to write 2 times. So straight away you write py equals to gx plus c. C is b minus a. So we no need to write 2 times. So the final answer is py equals to gx plus c. Any question, class, here? I stop here. I want to ask you question. Any question, class? Okay. No problem. Okay. Okay. Any question, class, so far? Yeah, any question? Patricia? Any question, class, so far? Clear? Farasha? Okay. Now, next time, you no need to write A, B. Don't write A, B. Just C enough. The question is how to find C. How to find C. That's why we need initial condition. And we call that as an initial value problem. So you study Rangekota, you study Yoon's method, you studied Euler method. You saw in the beginning itself, they already given the X and Y value. That is what we call initial condition. So the initial condition, given or not given, depend on the problem. If it is given, then you can find the C. If it's not given, you just put C. You cannot say C is 0. No. And if you write Px equals to Gx without C, unacceptable. You see, this is what I told you just now. Integration of Py dy equals to integration of Gx dx. The example 1, the Py is e power y power minus 2 e power minus 4y dy. You can try this, class. Equals to the right hand side, all must be x. Integration of x multiplied by e power 3x dx. I'm not sure whether you can solve the left hand side or not. It's a question mark. But right hand side is possible. You can try both left hand side, right hand side using integration by parts or any substitution method. There is one of the famous method in integration is called substitution method. It's very general, but the name is called as substitution method. So you can apply the substitution method to solve the problem. Now, so there are 2 steps, 2 steps. So we solve now with the example. Yeah. Any question, class? Okay. Yeah, Karen, you have to mute. Yeah. Easy, sir. Easy, sir. Okay. Good. So we carry on. We carry on. So you see the example. Solve the differential equation dy dx equals to y squared e power 3x. Some of you asking why they didn't give you the method. Question, solve by using separable method. Why they didn't give? They will not give because this is the question. So class, you cannot say why they didn't give you the method. Which method to use? Why they didn't give? So that question is irrelevant, unfortunately. So it is your duty. That's why I said the IFMO, if more. Identify form. Identify, then form, after form method, then output. I know all of you, you want the output. Unfortunately, this doesn't work because the output is for the engineers. And the method is already invented by the scientists. So you are in the last stage, the output. So we try, not guaranteed, we try. If this is separable, you proceed. If not separable, doesn't mean that you stop there. No, you have to go into the second one. That is 1.3, linear equation. If it is cannot be solved by linear equation, you go 1.4. That is exact, non-exact. Still, you cannot solve. Then you go 1.5. That is what we call Bernoulli. If it's still not Bernoulli, then the question is outside the syllabus. That means you haven't studied the method to solve the problem. That is, we can accept the fact that you cannot study because that is outside the syllabus. So within the syllabus, you cannot say this is not within the given the topics. So of course, we will not, you will not see any problem outside the syllabus. So that is, it doesn't make sense. So it must be within the 1.1 until 1.5. So dy dx equals to y squared e power 3x. We try this. We try to formulate this into separable form. Can or cannot, we have to make the decision. So here, the y squared, the dy over y squared equals to e power 3x dx. Left hand side, right hand side. So you see they follow the trend. The pattern is they put the y variable always left hand side. What is the reason? No reason. Just put y left hand side because you want to find the output y in terms of fx. But sometimes it is not possible also. So y power minus 2 dy, because 1 over y squared, you must put it y power minus 2, because we are going to use the famous rule called as power rule. P-O, P-O-W-R, power rule. This is one of the famous rule, very important, very significant in calculus. So we have to use the power rule in order to solve this problem. So the 1 over y squared, because the y squared, if you bring the left hand side, becomes 1 over y squared. So 1 over y squared, you must rewrite again as y power minus 2 dy equals to e power 3x. This dx, you must bring to right hand side. This y squared becomes left hand side minus y power minus 2 dy. Now you see whether this can be integrated or not. That is another step. Step 1, you separate it, separable. These steps are for the beginners class. But once you become very good, you are very good at solving, then you can skip all the steps. You can go directly and solve the problem. Now that is what the engineers want. So you don't go around the bush and then show all the steps. Now we are showing you because you want to learn first for the beginners. Later on you can cut short. You minimize your time because this is all time consuming. Now, how to integrate this? That is the question class. How to integrate this? You see they put integration sign, left hand side and right hand side. That is what we call, you want to perform the real hardcore method is integration. So y power minus 2, if you integrate y power minus 2 plus 1 minus 2 plus 1 minus 1. Y power minus 2 plus 1 divided by minus 2 plus 1 is minus 1. So the answer is y power minus 1 negative. So negative y power minus 1, you write as minus 1 over y. The reason is we don't want to write the answer like y power minus 1. So we want to write like this. This is the nice form, minus 1 over y. But you cannot say how to write y, because this is y power minus 1, negative y power minus 1 after integration. See, y power minus 2, we are using power rule. So y power minus 2 plus 1 divided by minus 1. So the answer is minus y power minus 1. You write minus 1 over y equals to e power 3x. You know how to integrate exponential function. There is a rule for the exponential function, e power 3x, because if you differentiate 3x is 3. So you must divide by 1 over 3. This is the answer. Plus 1 constant only, c. Like that. So now if you want to write y only, so this 1 over y, you bring this minus sign, can bring, because you want to write y, bring y is negative 1 over 1 over 3 e power 3x plus c. If you want to write y, in terms of x, but not necessary. This answer is acceptable already. You can stop here. Minus 1 over y equals to 1 over 3 e power 3x plus c is okay. This is acceptable. This is good answer already. This answer is okay. But you may wonder whether this can be simplified again or not. This is up to you. Because we want to write y as output single term. That means y power 1. But it is not necessary. Not necessary. Now class, minus 1 over y equals to 1 over 3 e power 3x plus c. Now I want to show you how to find c. When x0, let's say when x0, y is 1. Write down, yeah? Now we want to find the c, more in-depth studies. So this is called initial condition. Initial condition. So initial condition, now we do it together. When x equals to 0, your y equals to 1. Everyone, yeah? When x equals to 0, y equals to 1, what is your C? What is your C now? For this particular condition, when x equals 0, y equals to 1, what is your C? So
Zero.
you substitute negative 1 over 1, 1 over 3, e power 3x. 3 multiply 0, 0, e power 0 plus c. So c e power 0 is what? 1. So c is minus 1 plus minus 1 minus 1 over 3. What is your c? What is your c, class? E power 0 is 1. So c equals to minus 1 minus 1 over 3. So what is your c? C equals to what? I'm waiting for you. C equals to Shah minus 4 over 3. Very good. C equals to minus 4 over 3. Yeah, you are right. Okay, so now your answer will be this initial condition we can change. X0, Y1. If X1, Y2 is another condition. But for this particular C, your final answer will be minus 1 over minus 1 over y equals to 1 over 3 e power 3x minus 4 over 3. So this is your answer. So this is the complete answer. So now no more C. No more C. This is what you have to learn, class. This is what you have to learn. We don't want C. You must find C, but you cannot find C without the initial condition. So this problem, which I gave you just now, when x equals 0, y equals 1 is very important. This is what we call initial condition. I already wrote that. And then the whole problem become initial value problem. And this problem you can solve numerically using Euler method, Yoon's method, Runge-Kutta method. But you must have initial value. So you may ask, do I have to write y equals to minus 1 over e power 3x plus your c is minus 4 over 3. It is up to you, class. But for engineers, if you can reach up to this level, it's okay. This is acceptable. But if you write one more step, it's okay. Because this is what we call a simplified form. Now, this is the problem. This is the major problem because we have to apply the IFMO, if more method. Identify, form, method, and output. If more. Identify and form, and then method, and then output. So just now we already completed. So we already used the if more approach. Now, in this problem, you see 1 plus x. This is the tricky part. 1 plus x dy equals to y. This is not separable. So you have to separate the variable. So how do we do that? dy, this y, you must bring left hand side. This 1 plus x, you must bring right hand side. So how to write? You must follow the algebraic law. This dy over y equals to this dx, go here, right hand side, divide by 1 plus x. You must make sure you write properly like this. If you don't write, then algebraically you are incorrect. This is algebra. So algebra you studied in the past. So you must apply algebra in correct way. So you must observe carefully how to collect all the y term left hand side, all the x term right hand side. That is all about separable variables. All y terms, we call it grouping. You group all y terms left hand side and you group all x term right hand side. So we fix this method. Now you integrate. Integration is up to you how you do it. Integration of dy over y is ln y. Why they put the modular sign? Because they don't want y negative value. Y must be positive. So integration 1 over y is ln y. Integration of 1 over 1 plus x, if you differentiate x is 1. So ln x plus 1. Ln x plus 1 cannot be negative. This x cannot be negative. X plus 1 cannot be negative. That's why the modular sign plus c. They want to write y in terms of because this y, if you take y, then this is e ln x plus 1 c, because this is you can write this as e power c. It's also a constant. So you change the y, because this is e power c. You can write constant as you like, because this one is c. They can put it in this form, no problem. So if you take y, then e power x plus 1 c. So this one you can break into 2 power y e 1 multiply e power c. So in this case, e power c you can put it as a d, because e ln d is x plus 1. In here also you can have y x plus 1 is ready, because this ln you can take it off. But they write in terms of e power, and then back to same thing. So here you can write the c as e power c like this. Then it becomes d. So y is dx plus x plus 1. So this is your final answer. Y equals to dx plus 1. Because this c, actually c, you can put it as ln c, ln d. E power c is d, c is ln d. If I put c ln d, then you see this is ln y equals to ln x plus 1, and then c. The another way is I put c as a ln d. So ln y equals to ln x plus 1. C is ln d. So ln x plus 1 ln d is a multiplication. So y equals to d x plus 1. But x plus 1 here, no need to be negative or positive. Now you remove. You remove this, because they're no longer ln. So the final answer is y equals to dx plus 1. Even you put C, doesn't matter. So in this case, if I give you x1, y1, so what is your D? So y1, D, x1 plus 1. So 1 equals to 2D. So your D is 1 over 2. So your final answer is y of x plus 1. For which initial condition? x1, y1. So you put initial condition. We are slide 12. Yeah. Can I know which slide you are on? I think I'm looking at wrong slide. Yeah, slide number 12. And now slide 13. When can? Why cannot hear? Yeah, Chia. Slide 13 now. Yes, Chia. Go ahead. Yeah. Yes, Chia. You put up your hand. Chia. Yeah, when can? Okay, okay. Yes. Any problem? So for the x, slide 13, yeah, x equals to 1, y equals to 1. This is called initial condition. So you substitute x1, y1. So you get 2d equals to 1. So therefore, your d is 0.5 of. You can give decimal number. So your final answer will be y equals to 0.5 multiplied by x plus 1. Any question, class? For the example 2. Yeah, Karen. Any question, Karen? Yeah, any question? When can, okay. No. So example 2, are you okay? Example 2. Now, example 3. You see example 3, they gave you the initial condition. Look at example 3. Solve dy dx equals to minus x over y. So you bring left hand side y dy minus x right hand side dx. So integrate y dy minus x dx. So integration of y dy is y squared over 2 equals to integration of minus x squared over 2 plus c. Can you get that answer, class? Hello? Can you get the answer? Y squared over 2. Yeah. Y squared over 2 equals to minus x squared over 2 plus c. All right. Now we want to find the C. So what is the meaning of this? This is called initial condition. What is initial condition? When X is 4, your Y is 3. This is called the initial input, initial output. So why they give you this condition? Because you haven't found the value for C. That's why this answer is incomplete. So for engineering problem, you must find the value for C. So our answer just now, y squared over 2 equals to minus x squared over 2 plus C. So what is C? You substitute x equals to 3, x equals to 4, y equals to 3. Follow, yeah? Take piece of paper, write down. Y squared, 3 squared, 9 over 2, minus x squared, 4 squared, 16 over 2, plus C. So 9 over 2 equals to minus 8 plus C. So C equals to 9 over 2 plus 8. That is 9 over 2 is 4.5 plus 8. Answer is 12.5. So your C is equals to what? C equals to what? Answer please. C equals to what? C equals to 12.5. Or you can write yes. Or you can write 2, 9 plus 16, 25 over 2 also can. 25 over 2 also can. You can write in fraction or you can write in decimal number. It's up to you. Okay, any problem class? Any question so far? Any question so far? Any question? AQ, any question so far? Purushothaman, are you there, Purushothaman? Pru, are you there? Pru, Purushothaman. Farasha, are you okay, Farasha? Any question, Farasha? Farasha, any questions? Natasha? Natasha, any questions? Alif? Alif, any question? Okay, thank you, Natasha. Thank you. So, Patricia. What about Mohammed Irfan? Mohammed Irfan, any questions? Mohammed Nabil? Mohammed Nabil? Yes, Chia. Any questions, Chia? Mohammed Nabil, thank you. No question. Clear, sir. Thank you. Chia? Chia? Any question, Chia? Muhammad Amirul? Muhammad Amirul? Muhammad Amirul? Muhammad Amirul. Okay, thank you. So the next one is example 4. So example 4, y cos x. Okay. So take piece of paper, write down, yeah. Y cos x dy dx equals to ey sine 2x. So left hand side, y over e power y dy. Just write down first. Collect all the y terms left hand side. Y over e power y dy sine 2x over cos x dx. Now y over e power y, you must write as y e power minus y dy, left hand side, because 1 over e power y is e power minus y dy. Right hand side, sine 2x over cos x. You have to simplify. Sine 2x is 2 sine x divided by cos x dx. So cos x cancel off. You have 2 sine x dx. Y e power y dy. So this is what you should get. Okay, I write down here, yeah. So the left hand side, y multiplied by e power minus y dy equals to, simplify, integration of 2 sine x dx. Like this. Simplify already. This is called the format, the separable format. Now, the left hand side, y e power y dy, we must use integration by part. We try. Integration, you go back and check later on. Integration by parts. This is method. Separable is the format. So format also method, because when you talk about differential equation, the method is separable. But go more in depth, deeper and deeper, you have to perform in order to get the output. You must use the integration by parts. So what is integration by parts? It is a method in calculus. So you cannot say that this is not calculus. This is differential equation. For your information, calculus is the backbone of differential equation. Without integration, you cannot do differential equation. It is impossible. So the right hand side, integration of sine x is what? Right hand side. Anyone? Integration of sine x is what? Hello? Yeah. Integration of sine x is what? Right hand side. Anyone can answer? Yeah, Patricia. What is the answer? Integration of sine x. Minus cos x. Yes, correct. Yes. So you have minus 2 cos x plus c, right hand side. Minus cos x. What about left hand side? So e y multiplied by e power y dy. We use integration by part. Integration of u dv is uv minus v du. So you take u as y, dv as e minus y dy. Now we apply integration by part. So uv, u is y, dv is e minus y dy. Integrate e power y is e power minus y divided by minus 1. Minus integration of v minus e power minus y du is dy, differential y dy. So minus y e power minus y. This is plus integration of e power minus y minus e power minus y. So you have minus y e power minus y minus e power minus y equals to minus 2 cos x plus c. So you have minus minus minus. So you can write y e power minus y plus e power minus y equals to 2 cos x plus constant d. So you can put all plus plus plus. So you have e power minus y in the bracket, y plus 1, I can write like this, 2 cos x plus d, for example. So the answer will be e in the bracket, yeah, e power minus y bracket y plus 1 equals to 2 cos x plus a constant d. E power minus y plus 1 equals to 2 cos x plus d. Because just now minus 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 plus c. So I make it as a d. Now, so whatever it is, you look at the condition y0, 0. y0, 0. When x 0, y 0. So when x 0, y 0. So e power 0, 0 plus 1 equals to 2 cos 0 plus d. So e power 0 is 1. So 1 equals to cos 0 is 1. 2 plus d. So your d is 1 minus 2 minus 1. So your d is minus 1. Do you agree with that, class? So when y0, your d is minus 1. So your final answer will be e power minus y in the bracket y plus 1 simplified form equals to 2 cos x minus d. So you must write final answer like this. E power minus y in the bracket y plus 1 close bracket equals to 2 cos x minus 1. This is complete answer, class. So in this case, very hard for you to write y. So we no need to write y in terms of x. This is what you have to learn. It is not possible to write y in terms of x all the time. Cannot. Impossible. So whatever you get, the final output, y term on the left hand side, all x term on the right hand side, with the constant value d using the initial condition. Initial condition is given here, x0, y0. So if you look at the initial condition, this one, x0, y0. So if you substitute x0, y0, you will be able to find the constant. That is the ultimate goal of this problem. So for engineers, this is what they are very thirst and hungry for, because you cannot give the answer with the unknown constant. So in order to solve the unknown constant d, what is required is initial condition. There are two things here. Initial condition, IC. And then IVP. This is the short form. IVP. IC is the initial condition. IVP is initial value problem. So when they give you the initial condition, when they give you the IC, the whole problem becomes IVP. That is the meaning. Okay, any question, class, so far? Any question, class, so far? Okay, Natasha, all good, sir. No question. Thank you, Natasha. Thank you, Patricia. Thank you, Shah. So you can check the answer. You can check the answer. Muhammad Amir. Yeah, thank you, Muhammad Amir. Thank you, Muhammad Nabil. So you can check the answer. If your answer is different, let's say your answer is different, we can check by putting the initial condition. So that's why the IC is very important. The IC is very important because we can verify, we can validate, we can test. We can test your final answer is correct or not by using the IC, that is initial condition. So it is very easy to test, to validate, to verify, to check your answer if the initial condition is given. So you can write the final output in any form. Just now we wrote e power minus y in the bracket y plus 1 equals to 2 cos x plus d. If you write 2 cos x plus c also doesn't matter. You may ask, do I have to write in this form? Answer is no. You can write in any form. But the final answer, when the constant is applied, when the what we call the initial condition is applied, then the unknown must be the same. But the format, it can be in any form. So end of the day, the final answer will be the same, but the format may be different. So if I substitute x0, I must get my y0. That is fulfilling the initial condition, satisfied the initial condition. If the initial condition is not satisfied, then your answer is incorrect, unfortunately. So even your method is correct, but the initial condition must be satisfied. That's why we need algebra. So algebra is very important in order to solve the initial condition. So class, you go to some tutorial questions. So you can apply this method and solve some of the problem, not all. Tutorial question, take few, one or two problems, solve. So the most important thing is this example is a good example. So you can use this example to solve the problem. So we have a few more minutes. Can you see the slide now? Linear equation class? Can you see the slide? 1.3 linear equation. Tan, where are you, Tan? 1.3. Just give you a quick explanation. 1.3. So that we can stop. Thank you, Muhammad Sabil. Thank you. So this linear equation see slide number 4. Linear equation, you have 3 items. Again, the most important one is identify. Identify the standard form of linear differential equation. And then you must compute the integrating factor from linear differential equation. Then you solve. This is the output. So again, we apply if more. If more method is very important. If more, identify, form, method, output. Identify first, and then form. Must be linear differential equation. Then the method is called integrating factor. The method is integrating factor, and then find the output. So we can call this is if more approach, IFMO. So I'm not going to show you everything in detail. I cut short or simple one. The first order linear equation in the dependent variable y. Y is called output. So if they give you in this form, these are the form. General form, all these are linear equation. A1x dy dx plus a naught x y gx. You see the right hand side is gx only. So this is general form. So we need standard form. So what is standard form? Standard form is this one. These two are standard form. So A1, you must bring the right hand side. A0 over A1 is Pxy. And then the Gx over A1 is Fx. So dy dx plus Pxy equals to Fx. Sometimes we use Qx. You no need to repeat all the steps. Straight away, you use the output, get the answer. I will show you how to go from here. This is very special because this is the standard form. So the most important thing is finding the integrating factor. So I show you the most powerful shortcut method. This is, we use shortcut methodology. Dy dx, the format is important. The if more, identify form, and the method, we use the shortcut method. We call it shortcut methodology. So the identifying and the formatting the equation and the method and get the output. So I show you in 2 steps here. First, you must see the form in this form. If it's not in this form, cannot. Dy dx plus Pxy. This is Px, yeah, function of x only. Y cannot. Y is here. Y must be power 1. If y power 2 cannot. Y power 3 cannot. This one fx only. If you have a y here, cannot. So if this is the case, we have a limitation here. We cannot just simply solve any problem using this method, integrating factor method. Cannot. So the integrating factor is mu x. Mu x, function x only, equals to e power this px. You put it here. Take this px, put it here, integrate. E power integration of px dx. And that is your mu x. Write down, yeah? Step 1, this is step 1. This is step 2. E power px dx. Step 2 is finding mu x. What is mu x? Mu x is called integrating factor. Now the third step is, of course, this is the example. Dy dx minus 3y equals to 0. This is separable actually, but still you can, they are showing you how to find the integrating factor. Mu x is e power px. Px is minus 3 because in the problem, in the standard form is plus px. Why? So y is here, y power 1. But this is dy dx, first order. Your fx is 0. That is okay. This is fx 0. Your px minus 3. So e power minus 3 dx minus 3 take out. Integration of dx is x. So your mu x is this one. But what I want to show you is the method. So in this case, still this problem, if you want to solve, you no need to use integrating factor method because this is separable. Dy equals to dy dx equals to 3y. So dy over y 3 dx. So ln y equals to 3x plus c. So ln y equals to 3x plus c. This is the answer. Because this one is separable class. But here, but you cannot say this is not linear. It is linear. At same time, it is separable. So what you understood from here, the separable is inside the linear. Linear contains separable. So separable is subset of linear. That is the meaning of that. But this example one, just to show you how to calculate mu x. So in this case, mu x is e power minus 3x. Now, this problem is not in the linear form. Why? Because this one must be dy dx only. So there is a x here. You must bring x. Remove the x. So minus 4 over x, y, x power 6 divided by x, x power 5 ex. This is the tricky part. This one we call it linear, but not standard form. What is standard form? Standard form is this one. So dy dx minus 4xy x power 5 ex. So your px is minus 4x. Your fx is x power 5. Now the integrating factor is like this. E power px for x. You must be very careful in handling this one. This one minus outside. 4 you can take outside. 1 over x is ln x. But this one you must write like this. Ln x power minus 4. E ln x power 4 is 1 over x power 4. You cannot write in this form. This is very, what we call, not in a nice form. So 1 over x power 4. That is mu x. Now I want to show you how to solve the problem. After you find mu x, you see, rewrite this. This equation is general linear. But standard form must be in this form, dy dx plus pxy equals fx. Then integrating factor is mu x e power px. Now step 3, they're showing you all this. This is how they got it. So what we want is this one. We skip the step 3. We go to step 4. This is your final answer. So you take the final output y. You already found mu x. Just now I told you dy dx plus pxy equals to fx. Your mu x is e power px dx. Now straight away you write your y. Y is the output, is 1 over mu x in the bracket integration of mu x fx dx. Because this is this one one term all. So this is what we want. So when you solve the problem, straight away you go here directly. But you need mu x. Mu x is e power px dx. So you substitute mu x here. 1 over the denominator mu x. And you integrate mu x fx respect to dx. So you will have a plus c here. So the plus c we will find. Now you see this example. So 3 steps only. Yeah. Step 1, dy dx plus pxy equals to fx. Step 2, mu x equals to e power px dx. Step 3, y equals to 1 over mu x in the bracket integration of mu x fx dx fx dx. That's all. So we are showing you only 3 steps. 3 steps. You no need to repeat the method. 3 steps. So step 1, S1 is standard form. Standard form. Step 1. Step 2, find the mu x. And then step 3, output y. So output y, sorry, mu x. Not mu x, mu x. So you must remember the output y equals to 1 over mu x, integration of mu x fx dx. You must remember that. So applying this method, example 1, x dy dx minus 4y equals to x power 6 ex. You see all these are x term. And then y power 1. But this x not standard form. So you divide by x. dy dx minus 4xy, x power 5, x power 6 divided by x, x power 5 ex. This is what we call standard form. So step 1 is clear, standard form. So from here, you write down px because we need mu x. So px is minus 4x because this is minus 4x. And fx is x power 5 e power x. So step 2, you find your mu x. Straight away find mu x. E power px dx, e power minus 4x dx. So minus 4 take out, e power minus 4, integration of 1 over x is ln x, the natural logarithm x. And this is not in a good form. So you must write e power ln x power minus 4 is 1 over x power 4. Now, straight away you go to final. This is what I'm talking about, step 3. So this is the very powerful method. Y equals to 1 over mu x. So mu x is 1 over x power 4. So 1 over x power 4 is x power 4. Here mu x 1 over x power 4. Fx x power 5 ex. Integrate respect to dx. You integrate this. And now the x power 4 is outside. You have to be careful. That's why I said this one, you put it in the bracket. So integration x ex dx. This one, you apply integration by part. U dv. uv minus v du. uv minus v du. So x ex minus ex plus c. But this c must be together with x power 4. So you simplify x power 5 ex minus x power 4 x plus e x power 4. So this is your final output. Y equals to x power 5 ex minus x power 4 ex plus c x power 4. Any question, class? Any question? Any question, class? No questions, sir. Ciao. Thank you, Ciao. So we look at next example. Example 2, you can see this one, but no exercise is given. So you can look at example 2. But example 2 actually is separable. So this is separable. So because this is 0. If this is 0, it becomes separable. So no need to use this one, this method. So you can, because this is 0. So you use separable. This one, I can use separable. This one, y, you bring dy dx, x squared minus 9 dy dx equals to minus xy. So dy over y minus x over x squared minus 9 dx. So integrate ln y. This is minus this is 2x. So minus half ln x squared minus 9 plus c. So the answer is you can get yeah, you can simplify this. It's up to you how you do it. Ln y equals to minus half ln x squared minus 9 plus c. So they simplify this form. So they got the answer y c over root x squared minus 9. This is, yeah, you can write in this form or any other form. But what I got is using separable, ln y equals half ln x squared minus 9 plus c. This also okay. So I think that's all for today class. So if you have any questions, we will stop here. Any question, class? So that's all for today. So if you have any question, then you can ask me. Otherwise, we will stop here. All right. So very good. So take care. Very good. Take care for your take care. Take care for your test one. I think for test one, you have to submit to the email 1 hour only. So you revise chapter 1 and chapter 2. I cannot do chapter 2 today because chapter 2 we have homogeneous, inhomogeneous, and constant coefficient method and Wronskian. So I wish you all the best. All the best. All the best to all of you. And have a good day. A good day, and sorry for any inconvenient cause. Please fill up the whole satisfaction form. Please fill up one time only, yeah? Whole satisfaction form. So there is some glitches just now. If you cannot see the slide, then you have to go check in ulearn, yeah? Check in ulearn for test 1. Check in the ulearn, read the instruction carefully. I think 4 questions. I think 4 questions you must do within 1 hour. So quickly you upload, sorry, not upload. You send your answer script, name, your ID clearly, your name, your program, and your ID. For test 1, test 1, please write your name, your ID, and program. So I think the submission is via email. Submission your answer. So you send to my email. So that's what I heard from Dr. Mohana. 4 questions. I suspect 2 questions from chapter 1, 2 questions from chapter 2. So I think you must revise the Wronskian method and undetermined coefficient for the inhomogeneous, and then exact, non-exact, as well as Bernoulli. Take care of that, Bernoulli. Maybe this possibility is there, Bernoulli linear. Bernoulli linear and undetermined coefficient, as well as Wronskian. So this is my guess. but I'm not sure the detail. Let us see tonight. Any question, class? Any more questions before we stop? No questions? Thank you. All right. Okay. So we shall stop here. I'm not sure. I'm not sure what will come out. So I heard Dr. Mona give them 15 minutes for submission. Yes, yes. Yes, Roger. For what will come? What will come is chapter 1 and 2. I'm not sure. Chapter 1 and 2. Sir, repeat back. What is that? Muhammad Afif, what do you mean by repeat? What is repeat? Sir, what is that? Submission via email. Your solution, you submit via email. And you must write your name, ID, and program. Read the instruction. And then you can email me if you have face any problem. Yeah. So any difficulties, we will consider. We will consider all problems. You let me know if you have any problems. Please let me know any problems. So for the replacement for the quiz 2 next week, yeah. So take note, quiz 2 next week. Chapter 3 and 4. So okay, class. Thank you. So we will stop here. Right? Any questions? I will let you know later about the quiz. Yeah, I'm just giving you initial, early information only. So now you focus on your test 1 first. Okay. So we stop here. Huh? Thank you very much. Have a nice day. And don't forget to do your test one.
you